Okay, so hi everyone, Senan this side, and today we are going to solve this LeetCode daily problem. I know it's quite late because I had a lot of things to do, some quizzes, and if you hear some noise, that's just because there is construction going on in the hostel. Anyways, so what my job for today is, I will make you understand this problem completely, and we'll go over a dry run, and I'll show you the code of exactly how do you implement each and everything. So what I want you to do is to stick to the end of this video, because if you don't, I cannot actually do that. I'll try to be as concise as possible. And so let's get started with the question. So what you're given is basically a fraction, and you have to do addition and subtraction. So you would be given a string expression representing an expression or of fraction, addition, subtraction. So you only have addition and subtraction as the operations, and you would be surely given a fraction. Right, the final result should be an irreducible fraction. So irreducible fractions is basically meaning the two numbers are co-primes. And what is a co-prime? Co-prime are basically, when do we call two numbers as co-prime? The time when they do not share any common factor other than 1. Okay, so if your final answer is an integer, change it to the format of fraction. So even if we get a solid integer, we just like this, we just return 2 by 1. Okay, so I hope you understand the question. Just pause the video if you don't, just give it a good view, and let's get on to the test case. Okay, so you are given this, and minus half plus half is basically 0, so you return 0 by 1. Minus half plus 1 by 3 is again the first part is 0, and then you return 1 by 3. Okay, the last thing is 1 by 3 minus 1 by 2 is minus 1 by 6, obviously. So looking at these test cases, let's see if we, so let's look at the constraints first before I get into the explanation. Input string only contains 0 to 9, slash, plus and minus, so does the output. Fine. Each fraction input and output has the format plus minus numerator slash denominator. If the numerator, if this number is positive, plus will be omitted. So the answer should do the same, right? The input only contains valid irreducible fractions where the numerator and denominator of each fraction will always be in the range this. If the denominator is 1, it means the fraction is actually an integer. A fraction format defined, the number of given fractions will be in the range 1 to 10, and the numerator and denominator of the final result are guaranteed to be valid and in the range 32-bit. So the last point is very important, because you have to convert whatever the number is into an integer to do the calculations. Right, now what could be the wrong approach? Okay, the first wrong approach is, before that, clearly you have a string input and a string output, so there is some string manipulation to be done. You need to extract these numbers from this basically string, and you have to do some calculations by converting this into integer, float, double. Although we would use integer, but hypothetically, without knowing the question, we know that we have to extract this number somehow and do the operations like we normally do. Okay, now the wrong way to approach this question would be, which was the very first thing that came into my mind, is let's do the iteration through the string and extract minus half, store it into a float, then extract plus half and store it into a float. And the problem with that approach is basically, first of all, if you do calculations in floating point numbers in double, right, so there are some rounding off and rounding errors that accumulate along the time, so this might not give you the correct answer. On the other hand, if, let's say, if floating point evaluations in our system is exact, which is not true at all, because we only have at max 64 bits to store a float, or maybe store a double, and we can only have a finite representation of numbers, so we are losing out on information. Other thing, problem would be with floating point numbers is, let's say you have an exact solution for this, which is 0.5, and for this as well. If you add this, let's say you get 0, but when you add this 1 by 3, so you will get 0.33333 something and 4. Okay, so you get that using 0.33333 through as many expansion allows. How will you convert that back to this? Or let's say you have something like this, the exact value of 1 by 6. How do you convert this number back to this float number back to 1 by 6? That's very difficult. So for that means we have to find a different approach to do this. And let's take basically this example and do a dry run, and then we'll see how to code that And yep, okay, so the problem we had in our hand is minus 1 by 2 plus 1 by 2 plus 1 by 3, something like that. Okay, so let's assume this is our problem. So minus half plus 1/3, and you need to find the answer, which is 1 by 3 somehow. Okay, now how do you proceed? So what I'll do is I'll show you a method that we are going to use. So how do we, let's say we have these two fractions, right? So how do we add this? So let's say minus 1 by 2 plus 2, plus 2, 1 by 2. And what you can do is basically multiply this with this, and then as the numerator. So this times this plus this times this will give you the new numerator. Let's do that, which is equal to 2 times minus 1 is 2 plus 2 times 1 is plus 2, and which is basically 0 by something. And we obviously we can carry out this, we can just return 0. But let's see now, if we take this 2 and this 2, then we would have to write 2 times 2, which is 4. So 0 by 4 is the answer for this problem. Okay, we have that. Now what I do is I just take this 0 by 4, let's say 0 by 4, and what I do is now I add 1 by 3. And along the same lines, if I do this, we'll get 3 times 0 plus 1 times 4 by 4 times 3, which is what? This is 0 plus 4, 4 times 3, which is what again? It's 4 by 4, 3. And if you just cancel these 4 out, you'll get 1 by 4. So in the end, we'll see how to do this cancellation, but I think you get the approach. We are not doing this calculation in floating point array. We are doing this calculation using integers. You get this denominator, you get this denominator, you multiply them, the final answer. And what you do is you cross multiply these denominator with the opposing numerator, add them up, and you get the final answer like this. I hope you get the idea, and that is what we are going to do. Let's keep some idea of, so some pointers. Say we keep a track of negative. So negative 1 means it's positive, and minus 1 means negative. Okay, so the naming might not be the most efficient one or the most obvious one, but I started with keeping this negative as a boolean, but keeping this negative as an integer was actually helping me a lot. And I keep the so initial, while we were doing this operation, right? So we assumed that the first number we had was 0 by 1, which is 0. So that is what we are going to do. So I'll initialize this numerator as 0, denominator as 1, because denominator cannot be 0, right? Because that would be not a valid fraction. Okay, so just so you know, I do not have my laptop in the proper orientation. That is why I'm writing this a bit diagonally. Okay, so I hope you get till now. What I'll do is I'll just write the string minus 1 slash 2 plus 1 slash 2 plus 1 slash 3, and this string. Now what I'll do is basic take a pointer, and I'll initialize this to the first location, right? At this, now this arrow is pointing to minus 1, minus sign. So what I'll do is or let me just rewrite everything so that it's cleaner. Okay, so we are back again. So we have our pointer point and initializing negative as 1. That means it's a positive till now. I'm assuming that it's not sure. So what I do, I've seen a minus 1, right? Minus sign. That means the number I'm going to see after this, right? When I'm seeing the number after this is a negative, so I initialize that to this value. So I do is I take this minus and I substitute it minus 1. Now I take this pointer and I'll move this to the second, so it is a digit, right? So you can just easily do the comparison of the characters in C or Java, even in Python. You can do the comparison to check if it is a number. So what I'll do is I'll extract this number out, right? And how do I do that? So let's say it's not exactly related to this. Look at this test case. Let's say 1024 is your string, and you're trying to iterate from left to right. So how do you get your number? So I'll say, let's say num to 0, and I'll take this number, I'll multiply this num. So what I'll do is I'll do this operation on repeat in a loop. Num is equal to 10 times num plus digit. So initially num is 0. So what I do is I multiply it by 10, and then add 0, or basically add 1, because I'm seeing this one, right? So my new num is now 1. Now what I do is I multiply it now I see this one, and what I do is I see a 0, so I multiply the num by 10 and add 0. Now I have the number not 1 but 10. Now what I do is I see this 2, I multiply 10 by 10 to get 100, and then I add the 2. So now I have the number not 10 but I have the number 102. Now again, when I see this last 4, I multiply this by 10 and then add this digit 4. So in the end, I would be having 1024 as my number. So although this is an integer, right? So what would be happening is from the string, I converted that to an int. Similarly, to convert back to the string, you could do the similar process. Not exactly like this. You can just do the reverse conversion as well. But that is how you get from a string number to an actual number. So that is what I'm going to do. Since we only have a single digit, we will be done in a single pass. But let's say you have not one, let's say you have 11 111. Let's say you have to do this iteration, like, so we would parse the first number using a while loop when we are going to see the. So for that, for that reason I was just showing you this. So now what I do is I say my current, what I'll say is my current number is 1, my current denominator is, so current denominator we don't know. So since we have parsed this one, what I'll do is I'll go to the slash, and now I'll see, so this is slash. I'm done with the numerator, right? I am done with the numerator. By seeing the slash, I know I've seen the first half of the number. Now I have to see the second half of the number. Half, I mean the numerator and denominator. Now again, after I've seen this, I'll take this iterate. I'll find out the next number, right? And what would be the next number? Next number is what I got is, so now basically what I have is I have 1 by 2. So initially what I did, I started with 0 by 1. I'm adding this with 1 by 2, and since negative is -1, I multiply this with the value of negative. So I take the numerator and I multiply this -1. Not exactly here, but let's see how do we. Now we have to update this num and this denominator. How do we do that? Again, the numerator would now be defined as the numerator, which is the current thing, this one, times this this denominator. This would be numerator times current denominator. Then I'll do a plus sign, and what I do is do the opposite, right? This times this. So this is what? This is my current denominator. This denominator times the current numerator. Denominator times current numerator. Now after that, since we know that this number is not exactly a positive half, we had a negative number, right? So the actual fraction is this. So what I do is I multiply, in this case I multiply this by negative. So this is why I took negative as a integer and not as a bool. Current numerator opposites denominator, current denominator plus current denominator times opposites numerator times negative value, and you reassign that value to num. And how do you reinitialize the denominator? Okay, so what will be the denominator? The product of these two elements, which is denominator times current denominator. And just so you know, in the denominator you would never see a minus sign, because if it exists, it's already passed on to the numerator. Although for simplicity, in the code it's not exactly explained in that way, but so you know what is actually happening. Now we are done first iteration. Let me just remove this, right? Delete. And what I would do is I'll initialize my num again. So my num would be what? My num would be 1. My denominator would be 2, right? So we had 1/2 and negative is -1. Okay, so before that, num is not 1, but num is basically -1, because this value would have been 0 and we are multiplying this negative. So that was the mistake I did. Anyways, now what I do after doing this iteration, what I do is I reinitialize. So I make this again +1. I initialize this to 0. I initialize this to 0. Or you could just initialize it to anything else, but 0 is best till the time you don't find it, because these numbers would anyways be substituted with new numbers, right? So regardless of the value you place here, this would be later on updated, but having 0 is easy to convert this string to an integer. So for that reason, you would have to initialize this to 0. You cannot initialize to anything. That was wrong. You have to initialize this to 0, because you need, while we did the calculation of parsing the string, we need the initialization to 0. Now what I do is I take this iterator, I go one step ahead, I see a plus sign. so I don't update this. Either I update this to 1 again, right, or I leave it as it is. So after this, I again go here. I get C1. I parse this current num. I update this to 1. I move one step ahead. I see a slash. That means that now I am updating the denominator, right? So after that, step ahead, I parse this 2, and what I would do is update this to 2. Now I'll do the same cross multiplication. So what we have is, initially we had -1 and 2, and now we have +1 by 2. Now you do this cross multiplication and this multiplication, do the numerator and denominator. What you would get is denominator is 4 and numerator is 0. So let's do the update. So I update denominator 4 and numerator to 0. I think in the last iteration I did, so no, I did correctly. Okay, after this I initialize this again back to 1. I just remove this and I again initialize this to 0. Now after doing this, I have my number as 0 over 4 and plus something, and now I'll take this iterator. I've seen this plus, I keep this negative, so I keep this as 1. I've seen a plus, I take this iterator, I parse this first number, I initialize that value. This would be now 1. I take the iterator again, I see a slash, I know this current number is done, and now I proceed on with calculating the denominator. I take this step ahead, I parse this 3, I get the value as 3, and in the end we would be left with 1 by 3. So now you do the cross multiplication. If you do 3 times 0 plus 4 times 1, basically 4, and 4 times 3 is 12, which is what we got earlier. So what you do is you update this value to 4 and this value to 12. You are done now, literally done. Now the only thing is, you need to understand, you have 4 by 12. How do you convert this to 1 by 3? And to do this, if you know some basic maths, you would have heard greatest common divisor, and greatest common divisor is the biggest fact that they both share in common. So what we do is basically calculate this GCD of this 4 and 12, basically pass numerator and denominator as GCD, right? And what I do is basically, so if you find the GCD 4, because 4 divides the numerator and denominator, so what I do is I divide this by 4, divide this by 4, and what you get is 1 by 3, and you create a string of this format and just return that value. So what this would do is, let's say if you had your answer as 12 by 1, or let's say 12 by 2, you would find the GCD as 2, so you'll divide both numerator and denominator by 2. So what you will get is 6 over 1, and in the end you would always return the answer as 6/1. Fine, understood? How do we write this GCD function? To write, we will use Euclidean's method. Euclidean's method is the most classic way to find the GCD. So GCD is way of a comma b is, what I do is return, if b is equal to 0, what you do is return a, and I'll show you a dry run of this code, but this is the classic way that you write. Otherwise you just return GCD of what do you return? Return GCD of b comma a modulo. That is the most classic way. You would have studied this algorithm, Euclidean algorithm. If not, just go over YouTube, you would find a lot of great resources for this. But let's just do a dry run of this, how it will be working. So GCD of what two numbers did we look for? 4 and 12, right? 4 and 12. For this I would have to find the GCD. So how do I do that? So first I see, so first b is, so is 12 0? I would say no, clearly not. So what you do is you call GCD, you go to this statement, you call GCD of 12 comma what 4 modulo 12, which is what GCD of 12 comma 4. You know this, GCD of 12 and 4. So 4 modulo 12 is 4, just so you know. 4 modulo is just basically to finding the remainder. Now what GCD 12 would do is check, is this 4 0? We have to give b 0, so b is 4 in this case. So is this 4 0? So 4 is not 0, right? So you do another, so you would call GCD of what? GCD of 4 comma 12 modulo 4. And what is 12 modulo 4? Because 12 is completely divisible, this value would be 4 comma 0, and GCD basically equal to this. And now you see, in this case we have it as 0, so you have GCD as 4, and this is what we wanted, right? We wanted this 4 and we got it using GCD. Fine. Let's just for your clarification, let's calculate GCD of, let's say, any two numbers let's calculate GCD of 24 and 36. It's not exactly related to this problem, but let's do the calculation. So I hope you remember I would check initially if 36, if this value is 0. No, it's not. So what I would do is in turn call GCD of 36 comma 24 modulo 36, which is what? GCD of 36 comma 24. Okay, you're good with this. Now what do? Is I say is 24. No, it's not. Then I do the again calculation of GCD. I say GCD of 24 comma 30 modulo 24. Correct, right? What is 36 modulo 24? It's basically 12. So GCD of 24 comma 12 is what is being called, right? Now I do check if this 12 is what? It's 12 0. No, it's not 0. So this in turn would call GCD of 12 comma 24 modulo 12. Now I hope you're seeing where this is going, right? And what is this 24 modulo 12? If you know it, GCD of 12 comma this is basically equal to GCD of 0, because you can divide 24 by 12, right? So what is the GCD? GCD is, we see this value of B is 0, so we return 12, and we know GCD of 24 and is actually 12, because 12 divides 36 and 24, both of them, but no number greater than 12 would divide both 24 and 30. So that is the basic idea. I hope you were able to get this, and I'll just go over through this example once more. So that was for a different explanation. Anyways, we were at this position, right? So what we did was we initially started with 0 by 1, and by 1 we passed a fraction keeping track of the sign, and we updated our numerator and denominator, and in the end we would be having our solution stored in them. After storing that, we basically find the GCD, the elements, and we just somehow convert this format to a string format and return that as an answer. So this was a very long explanation. I hope you were able to get that. If not, we'll see the C++, and after that you'll have a pretty good idea that what we are trying to do. Okay, so let's go towards the code. So here we are back on my screen. So let's look at this code. So I first of all declare an answer string, which in the end I would return. I would declare n as the size of the array and an iterator I. Fine. And what I do is I keep track of this negative, initialize it to 1. I have this num and den as 0 and 1, current num and current den as 0 again. Okay, so we saw this, right? We saw this declaration in our declaration and initialization in our code as well. And this is basically the pointer or array that we have used to parse the string. Now, initially what I do is while I is less than n. So basically I would be traversing the whole string, and whenever it sees something else, slash or plus, we know that we have reached either the half of the fraction or we have calculated the value till that point. So what I do is, this is plus, I make the negative as 1, or I could use the variable sign, that would have been better. And if this is minus, I initialize this to minus, because the reason I did this negative is because I initialized this to bool earlier, because negative is bool or false, and depending on the value of negative, I was adding or subtracting this. I found this to be easier. I forgot to change the variable name, but I still kept it. Now what I do is, if I find a plus or if I find a minus, I automatically update the value this has. Now what I do is, if it is neither of them, right, it's not nor plus nor minus, that means we are on a digit or a slash. It cannot be a slash, because a plus or minus, we cannot have a slash, because assuming that the input is a valid input. So that means we are at a number. If neither of these cases are true, we are at a number. So what I do is, I'm parsing the number, right? You see, I told you current number is equal to 10 times current number plus the digit. So since expression of I is a character, first of all I check if between this the valid range. If it is in valid range, I take that value, I subtract 0, and I just typecast that to int forcefully, and basically this would give you the digit in an integer format, what is stored in a character format in this expression string. And you just multiply this 10 times current num plus this digit, and you get the new value of current num, and you increment the I, and you do this till the time you are not at a position I which is a digit, right? So what that means, since you got into this while loop, that means you are trying to find the numerator. So whenever this condition is false, that means we have seen a slash sign, the division sign, this slash or division sign. So that means okay, I've seen a slash, I just do I plus plus, and what I do is I do the same thing like what I did here for the denominator. Fine, so I did exactly same thing. So I have numerator and denominator. This is basically the parsing of the string. I got the number numerator, I got the denominator, and I do this. Numerator is this, denominator is this, and current numerator is I. Now after I have passed and initialized the new numerator and denominator, I reinitialize these variables. Now what I do is I get the sign of this. I use the same variable to determine the final size of this expression. So how did I get that is basically you take the sign of num and you take the sign of denominator or numerator, you multiply both of them. If both of them is negative, your final output will be positive. Either of one is negative and this is positive, which is negative. If both of them is positive, you get the value of them as positive. Now I have the final answer, the sign of the final answer stored in this negative variable. I just reuse this variable, right? Now I reinitialize this num to absolute of num, denominator to absolute value of denominator, since we have considered these signs, because passing a positive value in GCD would give you a, like, you don't have to worry about it. So now what is the divisor, which divide the number that can divide both of these numerator and denominator, I get using this GCD function. And how did I basically write the GCD is exactly what I showed you. If b is 0, return a, otherwise GCD of b and a modulo b. So this is basically a log n time algorithm, and where n is the value of the number a and b. It could be as fast as instantly big of 1, can also take log n time. Also, if you see the sign, how do I get the value of sign? If n is greater than 0 minus n is less than 0. So obviously you know if n is what? N is basically n is equal to 0. Either way, you get the point. So this is also working. So what is this doing is, if n is greater than 0, this value is 1 and this value is 0, right? Because this is false. So if n is positive, we get the value as 1. Let's say if n is negative, so n is less than 0. So that means if n is less than 0, that means this value is 1 and times minus, so minus 1, and this value would be 0. So 0 minus 1 is minus 1. So if n is negative, this would return minus 1, and if n is 0, both of them is false. So the final answer would be 0. The sign would be 0. So anyways, obviously if a number is 0, then obviously if numerator is 0, the final value is not any of our concerns, because the final, when we are doing this, you would anyways have 0 in your answer. I get numerator, denominator, and I get the divisor. And what I do is I take this number negative, which I found the sign of the final expression, times num, and divide this. So I divide this num by divisor to get the irreducible fractions, to basically make these two, numerator and denominator, as co-primes. Now what you do is you convert that to a string, you append this with the slash, and you convert this denominator again to the irreducible fraction form, basically by dividing the GCD. And what you do is you just return this as an answer. So yep, that is what I did. Now some corner cases, we have these 3 test cases. I just test it for a single expression. If let's say it could fail at a single expression, right? So yep, this was the only corner case that I thought could be there, which point my my code could fail. If you see the accepted tag, we just basically, that's the highest, beats 100%, right? So yep, that was the whole video all about. I hope I was actually able to explain you each and everything, and if I did, thank you for listening me. And yep, I'll see you in the next video. Bye.